Design for manufacturability, often referred to as DFM, is a critical concept in engineering that ensures products are designed with the manufacturing process in mind. In the context of printed circuit boards and computer-aided design workflows, DFM plays a vital role in bridging the gap between design intent and practical production capabilities. By considering manufacturability from the outset, engineers can avoid costly revisions, delays, and potential failures that may arise if key factors are overlooked. Early attention to DFM helps streamline the transition from prototype to mass production, reducing the likelihood of errors and inefficiencies. Neglecting these considerations can lead to increased expenses, compromised product quality, and missed deadlines. Ultimately, integrating DFM principles into PCB and CAD workflows supports smoother collaboration between design and manufacturing teams, resulting in more reliable and cost-effective products. The placement of components and the routing of electrical connections play a crucial role in the manufacturability of electronic assemblies. Thoughtful layout decisions can significantly reduce assembly time, minimize errors, and lower production costs. For example, grouping related components and aligning them with automated assembly processes can streamline soldering and inspection. Efficient routing not only ensures reliable signal integrity but also simplifies testing by providing clear access points for probes and diagnostic equipment. Designers often use techniques such as minimizing trace lengths, avoiding unnecessary crossovers, and keeping high-frequency paths short to enhance both performance and manufacturability. Additionally, considering the physical constraints of assembly machinery and test fixtures during the layout phase helps prevent costly redesigns. By optimizing component placement and routing, manufacturers can achieve higher yields and more consistent product quality. Thermal management and impedance control are essential factors in electronic design. Proper thermal management ensures that components operate within safe temperature ranges, preventing overheating and extending the lifespan of the system. Impedance control, on the other hand, is crucial for maintaining signal integrity, especially in high-speed circuits where mismatched impedances can lead to reflections and data errors. Addressing these considerations early in the design process helps avoid performance bottlenecks and reliability issues. Neglecting them can result in costly redesigns, delayed project timelines, and compromised product quality. By prioritizing thermal and impedance requirements from the outset, engineers can create robust, efficient systems that meet both functional and regulatory standards. Ensuring a seamless data handoff from design to manufacturing is critical for successful product development. Clear and comprehensive documentation plays a vital role, as it provides manufacturers with all necessary specifications, tolerances, and assembly instructions. Effective collaboration between design and production teams helps address potential ambiguities and prevents costly errors. Regular communication and feedback loops allow for early identification of issues, reducing delays and rework. By prioritizing transparency and thoroughness in documentation, organizations can facilitate a smoother transition, ultimately improving product quality and time to market.